Very good morning, students. Hope you all are doing good. Now, I would like to discuss the next concept in the interpolation and extrapolation chapter, which is Newton's advancing difference method. In the previous video, we had completed the binomial expansion method. All the problems we have completed from the binomial expansion method. Now, from the Newton's advancing difference method, how to estimate the missing term, whether it is a interpolating value or extrapolating. But in Newton's method, most probably we used to calculate only the interpolating value. Remember this is condition number 1. Comparison from binomial to Newton's method. In binomial expansion method, missing values, you can clearly see that one is in between, one is outside, right? But where in Newton's method, it will not be like outside, it will be always within. Remember, interpolation, Newton's method of interpolation, what we are going to observe, this concept, Newton's advancing difference method. Now, how the comparison between binomial expansion method and Newton's advancing difference method. Among these two methods, one common condition which is to be applied, that is common difference among independent variables x, right? So there must be a common difference. Even in binomial expansion also, how the x variables have some common differences, the same way even in the Newton's method also it has some common difference among between the independent variables x. Clear, guys? That is a common condition which you have to observe. So already I have discussed this part. This method is applicable in those cases where the independent variable x increases by equal intervals. Independent variable x increases by equal intervals. Increases by equal intervals. It doesn't mean that, it means that common difference, right? The distance between first variable and the second variable must have a common difference, and second to third also same, third to fourth also same. So this way, from x1, x2 and so on xn, so common difference must be there between the variables. Are you clear, guys? That is condition number 1. In this case, the independent variable x increases by equal intervals. Second condition, see, in binomial expansion method, clearly the missing values you can see. One is inter and one is outside in binomial expansion method. But where in Newton's method, it is not like that. In Newton's method, there is a slight difference. So in Newton's method, what we have to observe, like binomial expansion method, it is not necessary that the value of the y to be interpolated corresponds to one of the value of x. See here, x1, x2 and so on xn, y1, y2 and so on yn. See, in binomial expansion method, how we have to observe, the value which is to be interpolated must be the value of one of the value of x. Must be the value of one of the value of x. Even here also the missing must be the one of the value of x here, right? But wherein Newton's method, this method is not applicable. That means it need not be the missing value of one of the corresponding value of x. It may be in between also or anywhere in the table, right, which is to be interpolated from xn to x1 to xn. But usually there is a condition in Newton's method, the missing value what you need to be estimated, that must be in the initial stage itself. Okay, in between the initial stage only the missing value what they are going to be asked, isn't it? So that is the condition usually for Newton's method it will be given. Newton's formula should be used when the value to be interpolated is in the beginning of the data, remember, is in the beginning of the data, the value which is to be estimated, which is to be interpolated, missing value in the beginning of the data, and like binomial expansion, the missing need not be the value of particular x. It need not be the missing of particular x. It may be in between also. And whenever you see the table, you can see all the values. For example, 95, 97, 99, 2001, 2003. So all the values like this it will be given 20, 40, 30, 50, sorry 20, 40, 60, 70, 100. All the values will be given, but they will be asking find out 96 year missing value. So in between that two, in the beginning of the data. Are you clear? The reason is that the formula we take forward leading difference. The formula we take forward leading differences of the series. So that leading differences also I will be showing in the table. So why it is beginning of the data we are taking it. Are you clear, guys? So what are the two conditions to be applicable, applied for the Newton's advancing method? First condition is the independent variable x increases by equal intervals, nothing but a common difference among x independent variables. And second condition is like a binomial expansion method, the value which is to be interpolated, it need not be the one of the value of x. It need not be. Okay, it may be in between, right? Usually the Newton's advancing formula, how we is to apply? Whenever the missing value is in the beginning of the data, this is a condition as a note, remember. So at the beginning of the data, because we use the leading forward differences. From the beginning, the leading forward differences we will be calculating it. So that is the reason. What is the leading forward differences? I will be showing it later. Are you clear, guys? So these are the two conditions which are to be applied to estimate the missing value using Newton's advancing difference method. First and foremost, these conditions are to be followed clearly, right? Now let us see the procedure, how it will be, right? What is the formula of Newton's method of interpolation? Let us see the formula now. Now I am writing the formula, guys. So how to write the Newton's method of interpolation formula? Like binomial, by using the Pascal's triangle, directly we will expand the form, right? By considering the number of known values. But Newton's method is not like that. You have to write the formula, remember. So that is yx equals to y naught plus x into delta naught 1 plus x minus 1 by 2 factorial into delta naught 2 plus x minus 1 x minus 2 by 3 factorial into delta naught 3 plus x minus 1 x minus 2 x minus 3 by 4 factorial into delta naught 4 plus and so on. So this is the formula of Newton's advancing difference method. See, what is this y naught? The origin of y dependent variable, origin value, remember. And the same time, if n values of y are known, these n values are known. So number of known values also it depends. Depending upon n number of known values, we have to fix the leading difference term, which is delta naught 1, delta naught 2, delta naught 3, delta naught 4, delta naught 5. So depending upon number of known values, those many it will be getting it, remember. So the number of known values of y, if n values of y are known, then up to delta naught n, which is the nth leading difference, up to delta naught n we should calculate depending upon n known values, remember. You understand? Depending upon number of known values till that delta naught n, we have to do the leading difference. Are you clear, guys? Next, how to make the leading difference table. Let us see. So look at the formula once again. So there is the easiest way of learning the formula. Let us see that now. Look at here now. First, yx equals to y naught plus. So usually x by 1 factorial, x minus 1 by 2 factorial, x minus 1, x minus 2 by 3 factorial, x minus 1, x minus 2, x minus 3 by 4 factorial, plus and so on. After writing like this, here first leading difference delta naught 1, second leading difference delta naught 2, third leading difference delta naught 3, fourth leading difference delta naught 4. So this way you have to learn writing the formula of Newton's method. Now let us see the leading difference. Before that, here what we have learned, what is y naught? Y naught is, write down what is y naught, value of y at the origin. Value of y at the origin. Y naught, the initial, the first origin value of y dependent variables. Right? Next, what is x here? The x should be obtained by using the formula. The value of y which is to be interpolated for the given value x. Right? Yx is nothing but the value of y which is to be interpolated. What we need to be estimated at x place. That has to be written in place of yx. So yx is nothing but value of y which is to be interpolated at x. Which is to be interpolated at x, that is yx. Next, delta naught 1 is a first leading difference, delta naught 2 second leading difference, delta naught 3 third leading difference, and so on. So the leading differences. How to identify this delta naught 1, delta naught 2 and delta naught 3 from the leading differences table, I'll be showing after this explanation. Clear? So there, if I show that table, then you will easily understand how to identify the y naught as well as delta naught 1, delta naught 2, delta naught 3 and so on, the leading differences. Now, what is this x here? What is that x? X should be obtained by using the formula. What is that formula? This x how to obtain? Value which is to be interpolated means what is to be estimated, that value. Value which is to be interpolated minus value at origin. Right? The independent value of x at origin, x naught, divided by the difference between two adjoining values of x, nothing but a common difference we can write. Right? How to calculate this x value now? Value which is to be interpolated. Value which is to be interpolated. What? The value you have to estimate. In the question it will be given, right? That has to be taken here. And then minus origin value of x. Like how origin value of y you have written, same way the origin value of x has to be taken, x naught, divided by the common difference among the adjoining values of x. Remember, so that common difference must be taken. After calculating this one, you will be getting this x value. Got it? So this y naught and delta naught ones will be getting, delta naught 1, delta naught 2 will be getting from leading difference table. This x what is to be estimated, that formula, there is a formula to find out this x. In the formula if you want to substitute, the value which is to be interpolated minus the value of x at the origin divided by the common difference among the adjoining values of x. Clear guys? So by using this formula, you are going to estimate this value of x. Y naught value, the value at origin. X naught value, the value of x at the origin. Delta naught 1, delta naught 2, delta naught 3, delta naught 4 and so on. All those are leading differences. From the table you will be getting it. And then this x value which is to be observed by using the formula, what it is? Value which is to be interpolated minus x naught value, means value of x at the origin, divided by common difference among the x adjoining values. Are you clear? So this is how you need to learn writing the formula. Very simple formula guys. Even if I show the difference table also, problem will become very simple. So by using this formula, the value of y which is to be interpolated at x, we can get it. So let us see the difference table, the leading difference table now. Now look at here, the leading difference table, how it is to be calculated. First x, x0, x1, x2, x3, x4, x5. Next y, y0, y1, y2, y3, y4, y5. See guys, as I mentioned earlier, missing value will be definitely shown in the beginning of the data. Remember, so that is the easiest way to identify the Newton's advancing method. Second way of observing the method is, missings will not be shown in the table. Nowhere it will be shown the missing value, like binomial. Right, binomial definitely the missing value will be shown in both inter and extrapolating. But wherein here, missing value will not be shown, as if the data is given completely. That way only the table will be shown. Remember. Now, do the leading differences now. First, the first leading difference, shortcut I have written FLD. First leading difference. So first leading difference, what it is? This is delta 1. We can take it as delta 1. Right? First leading difference means forward leading differences. So for y0, what is the forward value? y1. The forward leading difference, that means y1 minus y0. You understand? Next here, y2 minus y1. Next, y3 minus y2. y4 minus y3. y5 minus y4. See here. From 6 values, it has been reduced to 5. The leading forward differences we have done. Leading forward differences means from down to top. y1 to y0, y2 to y1, y3 to y2, y4 to y3, y5 to y4. So this we can take it as delta naught 1. This is origin first leading difference at origin 0. This is delta naught 2. Sorry. So this we have to take it as delta. This is delta naught 1. This is delta 1 1. This is delta 2 1. This is delta 3 1. This is delta 4 1. Right? So delta 1 is common. So this is at origin, first place, second place, third place, fourth place. Next, second leading difference, forward leading difference, delta 2. How to take this one now? Between these two, again leading differences we have to observe. That is delta 1 1 minus delta naught 1. This will become delta naught 2. You understand guys? Next here, delta 2 1 minus delta 1 1. This will become delta 2 1. Delta 3 1 minus delta 2 1. This will become delta 2 2. Delta 4 1 minus delta 3 1. This will become delta 2 3. See here. After getting the first leading difference table, Again there also forward leading difference it has to be done. Here how many are there? First 1, 2, 3, 4, 5, 6 are there. Those have become 5. Now these 5 will become 4. These 4 will become 3 now. Third leading difference. Third leading difference. Just look very carefully, observe guys. Table. If you learn this table, then only you will be understanding the Newton's method. Remember. Now again leading differences. Delta 1, 2 minus delta naught 2. This will become delta naught 3. Next here. Delta 2, 2 minus delta 1, 2. This will become delta 1, 3. Delta 3, 2 minus delta 2, 2. This will become delta 2, 3. See here how it became now 3. Next, fourth leading difference. Fourth leading difference. As I mentioned earlier, depending upon number of known values, those many leading differences you will be getting it. Remember. Next, delta 1, 3 minus delta naught 3. This will become delta naught 4. Next, delta 2, 3 minus delta 1, 3. This will become delta 1, 4. Fourth leading difference. Next, fifth leading difference. Delta 1, 4 minus delta naught 4. This will become delta naught 5. See here, from 6 to reaching the single term, you should keep on doing the difference table. Remember guys, always. So this is how the difference table is to be calculated. In the problem, if I show, then easily, more than this, in the easiest manner, you will be understanding it. Remember. So first learn this difference table carefully. Right? See here. First leading difference, from 6 values, 5 it became. After 5, second leading difference, 4 it became. After 4, third leading difference, 3 it became. Afterwards, fourth, 2 it became. Fifth, single. Unless it reaches to the single term, we should keep on doing the differences, leading differences. Remember. So that too leading differences means down to top. 1 to 0, 2 to 1, 3 to 2. This way. The leading forward differences we have to calculate in the table. Clear? Even similarly, whenever they give the problem, you should do the leading differences. Now, the same leading differences, what is the formula? Yx equals to y naught plus delta naught 1 into x plus delta naught 2 into x minus 1 by 2 factorial plus delta naught 3 into x minus 1 x minus 2 by 3 factorial plus and so on. Now here see y naught. What is the value of y naught? This value. Then what is the value of delta naught 1? This first value. Delta naught 2, this first value. Delta naught 3, this first value. Delta naught 4, this first. Delta naught 5, first. Always we need to take the initial terms. Why we are taking the initial leading differences? Because the missing value is in the beginning of the data. Are you clear? The missing value, what is to be interpolated, is in the beginning of the data because of these leading differences. Always the origin value should be considered. Remember. Delta naught 1, delta naught 2, delta naught 3, delta naught 4, delta naught 5. Substitute here. And you know x how to be calculated. Value which is to be interpolated minus the value of x at origin divided by the common differences between x. That is how the x has to be calculated. Are you guys clear? Now, one dummy problem I will be taking it and I will show how the leading difference table we should consider. Let us see that now. Look at this example guys now. So what is to be estimated now? At x equals to 12, the value which is to be interpolated at x equals to 12, what is the value of y? At x equals to 12 means where it is? Here it will be, the beginning of the data. Right? The value which is to be interpolated at x equals to 12, the y value we should estimate. So definitely you must have understood that the answer comes between 5 and 7 only. Are you clear? See here, the table how it is given. Anywhere have you seen the missing is given? Provided? No. All the values are known. You understand? All the values are known here also, right? At the same time, there is like binomial, it need not be the value which is to be interpolated, must be one of the value of x. See here, value of y nowhere it is missing, and value of x where it is asked, somewhere in between. So for such kind of problems, we use Newton's advancing method. Remember. Now leading differences. First leading difference, delta 1. 5 minus 3, 2. 7 minus 5, 2. 8 minus 7, 1. 10 minus 8, 2. 12 minus 10, 2. You understand? Next, second leading difference. 2 minus 2, 0. 1 minus 2, minus 1. 2 minus 1, 1. 2 minus 2, 0. Leading difference, down to top I am subtracting. Remember guys. Next, delta 3, third leading difference. Minus 1 minus 0, minus 1. 1 minus of minus 1, 2. 0 minus 1, minus 1. That is third leading difference. Next, delta power 4. Fourth leading difference. 2 minus of minus 1. So 2 plus 1, 3. Minus 1 minus 2, minus 3. Next, the last leading difference, delta 5. Minus 3 minus 3. So minus 6. Now what we need to consider? This is x naught. This is y naught. This is delta naught 1. This is delta naught 2. This is delta naught 3. This is delta naught 4. This is delta naught 5. Got it? Now, from the formula, that is yx, y naught plus delta naught 1 into x plus delta naught 2 into x minus 1 by 2 factorial plus delta naught 3 into x minus 1 x minus 2 by 3 factorial. Up to where it is? Up to delta naught 5. Till delta naught 5 we have to take the formula. Delta naught 4 into x minus 1 x minus 2 x minus 3 by 4 factorial plus delta naught 5 into x minus 1 x minus 2 x minus 3 x minus 4 by 5 factorial. Till 5 factorial it has to be taken. Now what is value of y naught? 3. Delta naught 1, 2. Delta naught 2, 0. Delta naught 3, minus 1. Delta naught 4, 3. And delta naught 5, minus 6. Right? Now how this x to be calculated? Look at this x. Value which is to be interpolated. What is to be interpolated here? 12. 12 minus, what is the value of origin? X. 5 divided by, what is the common difference? 5. So what will be the answer now? 12 minus 5 is 7. 7 by 5. How much? 1.4. You got it? So what is the value of x here? 1.4. You understand guys? So that x value 1.4 you substitute here. Next, x minus 1 means 1.4 into 1.4 minus 1 divided by 2 factorial. You know factorials how to calculate, right? 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 into 2, 4 factorial is 4 into 3 into 2, 5 factorial is 5 into 4 into 3 into 2 into 1. 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. You know how to calculate the factorials, right? So substitute there. This is how the Newton's method is to be calculated, guys. Please follow this method thoroughly, because these are all just level 1 problems. Still there are some tricky kind of questions, twisted questions, right? Indirect, direct. There are many different ways to calculate the Newton's method. Just the initial method, by showing one example I have shown you. Clear? Please try to follow this, right? So learn the theory part first, Newton's, then later on problems we will be solving it. If you understand the theory means what you need to understand first, how to draw the leading difference table. That's the first point. Second one, how to learn the formula. Third thing is estimating this x value and substituting here, and simplification. So these are the three major steps. Anywhere one slight little plus or minus goes wrong here, anywhere, while doing leading differences, sometimes what people go wrong here is, here 1 is there, here minus 1 is there, they will cancel and they'll write 0. Wrong. We are doing difference between again these two. So 1 minus of minus 1, that means 1 plus 1, 2 it will become. Right? Where it has to be added, where it has to be subtracted, carefully you observe depending upon the signs. Clear? So that is what people go wrong in calculation many times, especially in Newton's advancing method. Binomial is simple, but Newton's method is lengthy, tricky and little difficult. So hope you understand. Follow the video thoroughly, then definitely this method you will be understanding it. Right guys? So with this, I'm going to wind up today's class. Let us meet in the next video. Thank you. Have a nice day.